All right, we have section 9.3 here on exponential growth and decay applications. So our goal here is to write and solve exponential growth and decay applications. And to make your life a little bit easier, these two formulas will be given to you. It's not going to tell you if it's exponential growth or decay. There's going to be two other equations with them. So you have to know which one to use and what all the variables stand for. So let's start with A. A is just the initial amount, the amount that you're starting with in the problem. Whoa. Oh, we'll jump all the way back down, but R is your rate. It's going to be given to you as a percent, so like 35%, for example. You need to convert that to a decimal before you use it in your equation. And then T is time in years, it says, but it could be days, hours. It just depends on the problem. And if you look at the decay model, the only difference between growth and decay is one, you add your rate to 1, take 1 plus your rate. In the other example, you take 1 minus your rate. Otherwise, they're the exact same thing. The variables stand for the exact same thing. So putting them to use here, write an exponential growth model. So it tells you, but usually you have to look for some keywords like population increases or something like that. So a business had $10,000 profit in 2003. Then the profit increased by 25% per year after that. What was the profit of the business after 10 years? So it tells us its growth, like I said. So we are using this formula right here. We just fill in the information, and it all becomes calculator work. So y equals A, our initial amount is 10,000. 1 plus R. R is my rate as a decimal, so that would be 0.25. And then T is my time. In this example, time would be 10 years. You could just punch it in your calculator like that, or you could clean it up here quickly. So this would just be 1.25 to the 10th power. If you go over to your calculator, you type that in. So we had 10,000, and then in parentheses 1.25. And if you want to do any exponent, you click this little caret off to the right underneath the clear button, and it allows you to type in any exponent we want to the 10th power. Hit enter, and there you go, 93,132. And then because we are talking money, we should just round appropriately. It'll change each problem. I'll let you make that decision yourself. But money, you should round to the nearest cent. So we'll go 0.26. And then make sure you have a label. And what in the world? And there you go, $93,132.26. Here's a population one. West Fargo's population is 35,000 people and increasing. There's your key word there. It tells you it is exponential growth by 8% each year. What will the population be in West Fargo in 9 years? So y equals A, 1 plus R to the T because it's growth. Our initial amount is 35,000. 1 plus R. My rate is here, 8% as a decimal, would be 0.08. And then T, my time is 9 years. So again, you can clean this up. Right, this says 1.08 to the 9th power. You type that into your calculator. So 35,000 people to start. 1.08. Missed the 1 there. And then to the 9th power. Hit enter. So now here, because we're talking population, I would round to the nearest whole person just because that makes sense rather than a point whatever of a person. So we'll go 69,965. And then again, just make sure you label it. We're talking people here. And that's all you need. It will say write your answer as a complete sentence, but I'm not so concerned about that. As long as you have a label and an appropriately rounded answer, you should be good to go. And then the last thing here, where you're given an equation, you just have to find the information from the equation. So it says the amount Y in grams of a sample of iodine after T days is given by this equation. What is the initial amount? Well, that's your A value, so we would say that that is 50 grams. And then, so first of all, looking at my number in the parentheses, because it's less than 1, it would be decay. So we have to figure out what percent it is decaying each day. You know, for example, here, the number inside parentheses was greater than 1, and also we knew it was growth because the population is increasing. So those rules still apply here. So this is exponential decay, but by how much? So what you're looking at is if it's growth, you want to know how much more than 1 you would have. So just an example here would be, so if that number inside the parentheses was like 1.18, to the t power, whatever, how much more than 1 is that? Well, it is 0.18 more, which is 18%. So that would be your growth rate or factor, whatever you want to call it. So when it's decay, you want to know how much less than 1. So we have 0.92. How much less than 1 is that? Quick subtraction would lead you to 0.08, which is 8%. And there you go. And that's basically it. There are a couple more examples here. They're both decay. It tells you they're decay, but car value decreasing, ibuprofen decreasing. So you can do those examples if you want, but it's all the same. Just remember that these equations, these formulas will be given. You have to know which is which and what the variables stand for. That's it.